Hi everyone. So today we're going to work on composition of two functions. So the other day we worked on adding, subtracting, multiplying, and dividing. This is a different type of operation with functions. So you have to think of it as kind of like putting one inside of another. Okay, so we're going to kind of take the letter out and replace it with something else. All right, so we're going to be able to find the composition of two or more functions. I think we're going to stick with just two. So here's our formal definition. The composition of a function g with function f is written as g composed of f. This little circle here means composition and is defined as g composed of f of x is equal to g of f of x, where the domain consists of all the x values in the domain for f, for which f of x is in the domain of g. We're not going to focus on domain, but that's part of the definition. All right, so g composed of f is equal to g of f of x. So here's what you're going to do. You're going to evaluate f of x first, and then use f of x as an input for g. And that sounds like a lot, but watch what happens. All right, and by the way, it doesn't go both ways. F composed of g and g composed of f are not the same thing, okay? So we want to make that clear. All right, so here's two functions, and we want to know what is f composed of g. So what that means is that we're going to take g, which is x squared. I'm going to come over here to f. I'm going to take out the x and replace it with x squared. Okay, so x squared goes in with the for the x, so it becomes x squared. X squared minus 5. So we take out the x and replace it with x squared. All right, so this says g of f of x, meaning g composed of f of x. So we're going to go to f of x this time. Okay, so we're going to go to f of x. We're going to take it, and we're going to take this entire thing. We're going to come over here, take out the x, and put that whole expression in for x. So take out the letter, okay? So we're going to take out the letter and replace it. So this is going to become x minus 5 quantity squared. Now we probably should write this twice and multiply, clean it up. And that would make it a little better. Now, okay, so in both of these problems, we've taken the expression and put one inside the other. What do you do if it's a number? Well, this says we're going to go to g of 3. So we're going to evaluate g of 3 first. Okay, so g was x squared. So this is going to be negative 3 squared, which is 9. Now, we're going to take that answer and find f of 9. Okay, so we're going to go 9 minus 5, which is 4. So f composed of g of negative 3 is 4. This guy right here is your final answer. Okay? All right, let's try some more because it does get confusing. All right, so you can think of this as another way to think of it. Okay, so if that's confusing, take g of x, which is x squared plus 1. Okay, so we now have evaluated g of x, and we're going to go f of x squared plus 1. So 3 x squared plus 1 plus 2, or 3x squared plus 3 plus 2, or 3x squared plus 5. Okay, so that's another way of thinking of it. Okay, whichever works best for you, whether you think of it as replacing the letter or taking it and putting it in f. I kind of like this way a little bit better, make it a little bit more easy to understand. Okay, so we're going to start, and I always start with the one closest to the variable. It's probably the best way to tell you. So we're going to always start with the one that's closest to the variable. So f of x is 3x plus 2. Okay. So now we're going to find g of 3x plus 2. Okay. So this is 3x plus 2 quantity squared plus 1. Okay, so that means write this twice. Okay, we have plus 1, so we're going to write it twice. So it's 9x squared plus 12x plus 4. Now, do it on the side, whatever method your box, split distribute, okay, FOIL, whichever method you're most comfortable with. Do some scratch work on the side like we've been talking about, and then come back into the problem. So 9x squared plus 12x plus 5. All right, so hopefully that makes a little bit more sense than my rambling about replacing the letter, okay? All right, so this says find f composed of g of 2, or f of g of 2. So let's find g of 2. Okay, so 2, so it'd be 2 squared plus 1. So 4 plus 1, or 5. And now we're going to find f of 5. Okay, so that's 3 times 5 plus 2. Okay, so that's 15 plus 2, or 17. So there's your answer. Okay, so let's try this one. F of x is 3x plus 2. So f of 3x plus 2 is 3x plus 2 plus 2. Okay, so that's 9x plus 6 plus 2, or 9x plus 8. Okay, all right. Let's try one more, okay? All right, so g composed of f of negative 3, so we're going to find f of negative 3 first. So negative 3 minus 5, which is negative 8. And then we're going to find g of negative 8. Okay, so what's g? X squared. So negative 8 squared is 64. Okay. All right, so I didn't make an assumption here that we knew how to evaluate a function. And I believe we went over that the other day. Okay, so this says g of f composed of g of negative 3. So we're going to find g of negative 3. So that's negative 3 squared, which is 9. And then we're going to find f of 9. And that's x minus 5. Okay, so 9 minus 5, which is 4. Why do I feel like we just did that problem? Oh, okay. All right, so let's find f composed of g composed of f of x. Well, f of x is x minus 5. So we need to find g of x minus 5. And I think g was x squared. I did believe we did this problem. 5 times x minus 5. I don't know why I have the same problem twice. Okay. All right, so f of 2a. Well, f is x minus 5, so we need to find f of 2a equals 2a minus 5. If you notice, we're working from the inside out, which we usually don't do. Oh, that's not it. There we go. So this is going to be 2a minus 10. Okay, so we noticed that we worked from the inside out in every single one of these. All right, so I kind of like that method a little bit better than the replacing of the x, but whichever one makes more sense to you. All right, let's try like why do we care, okay? A car dealer offers a 15% discount of the list price X of any car on the lot, which is really important because right now car prices are crazy. At the same time, the car manufacturer offers a $1,000 rebate for the purchase of the car. All right, so write a function to represent the price after the discount. All All right, so let's call this f of x. So if it's 15% off, you're paying 85% of the price. 0.85 of the price. Okay, represent the price after discount. So the price minus 1,000. All right, so let's say our price was $18,000. Use composition function to find the price of a car if the discount is applied before the rebate. So in other words, the discount is applied first. So that means G composed of f of x, okay, of 18,000. So we're going to find 18,000. And we're going to apply the discount first and then subtract the 1,000. So f of 18,000. So that's 8.85 times 18,000. Okay, I need my calculator for that because I don't have it up on my computer, my iPad here. My app that I use to record shuts off every time I open it up, so I can't open it up while I'm in mid-record here. So $15,300. Okay, so now we're going to find G of 15,300. So that means we're going to take 15,300 minus 1,000. So $14,300 for the price of the car. All right, so suppose the list price is 18,000. We're going to find the price of the car if the discount is applied Oh, did I mess that up? Yeah, after the rebate. I'm sorry, the rebate comes first. So we're going to find f composed of G of 18,000. Okay, so we're going to find G of 18,000, which is the discount. The rebate. Okay, so that's $17,000. And now we're going to take f of 17,000. So that's 0.85 times $17,000. Okay, I got $14,450. Okay, so as a consumer, we like the first one better. Give me my discount, then supply the rebate. But which one will the dealer want? The dealer would want discount for a rebate first, then apply the percentage off because there's less money to take the percentage of. So he would like f composed of G. Okay. All right. Let me know if you have any questions, guys. Stay safe out there, and I'll talk to you again real soon.